Okay, absolute value functions. Now, it's a little bit of a weird topic because we've actually done absolute values of more complicated things like vectors, and it meant length in that context. When we talk about a number, like the absolute value of 3, how long is 3? Well, it's 3 long. The absolute value of minus 5, well, that's 5 long. So essentially what you do with an absolute value is you just chuck out the negative sign. And just to justify that, sort of on a number line, if we look at 3 here, that is 3 units away from 0. And if we look at minus 5 here, that is positive 5 distance units away from 0. So that's sort of what we mean there. Okay, so if a is minus 2 and b is 6, we'll find all these things. Mod a is mod minus 2, which is 2. Mod b is mod 6, which is 6. Mod of AB is mod of minus 2 times 6, which is mod of minus 12, which is 12. Mod of A plus B is mod of minus 2 plus 6, which is mod of 4, which is 4. Mod of A plus mod of B is mod of minus 2 plus mod of 6, which is going to be 8. Well, 2 plus 6, I should do the middle step, which is 8. Now, one thing I want to note here is that we have something called the triangle inequality. Still holds for absolute values as well. So what the triangle inequality tells you is that mod of A plus B is always less than or equal to mod of A plus mod of B. And that's true. It's very useful to know that. Where it comes from is basically if you have A and B, usually it's like vectors here, but then this vector side length is A plus B, and then any two sides of a triangle must be longer than the third side, because this third side here is the shortest path between these two blue points. So sort of by definition, going along this path would be a detour. Anyway, remember that. A squared take 2b is going to be mod of minus 2 squared take 2 lots of 6, which is going to be mod of 4 take 12, which is mod of minus 8, which is 8. Cool. Next, let f of x equal x take mod x. Write f of x as a piecewise function. So this is without absolute value signs. So probably best thing we can do first is to think about let's think about another function. G of x is just normal mod x. Well, g of x equals, now it's going to be x if x is greater than 0, or it's going to be minus x if x is less than 0. So that's how that one works. You can think about it if we tried to work out g of minus 3 or something like that. We take the bottom branch, so it's going to be minus 3, which is 3. Yeah, we take the bottom branch here because x was less than 0. So you get an extra minus sign and flips it back to positive. Now, just coming into the land of graphing, you can write abs of x to get the absolute value signs. That's the same as the bars around the sides of it. You can see that if I plug in minus 2, the function spits out 2 because the absolute value of minus 2 is 2. And up here, it just mirrors the line y equals x. So you can sort of look at this piecewise function. Y equals x is greater than or equal to 0. And y equals minus x if x is less than 0. And those two blue and green bits will perfectly define the line absolute value of x, but you have to do it in 2 pieces. Okay, now let's see if we can do f of x equals x take mod x. So let's look at this. So f of x equals, now let's think about if x is greater than or equal to 0. So it's going to become x take, and then x won't change, so you get 0. And if x is less than 0, you're going to get x take, and you need another sign because you have to flip x back to positive. So this is 2x, just like that. So f of x is going to equal 0 if x is greater than or equal to 0, and it's going to equal 2x if x is less than 0. Wonderful stuff. So let's see if we can graph this. So get rid of all this stuff. The original function was x take absolute value of x, and we can see that it is sort of 0 up through here, and then it's that line down there. And if we want, we can define this in 2 pieces. So 0 if x is greater than or equal to 0, That's the purple bit. And minus 2x, we said, no, 2x, we said was the other bit. And that only applies if x is less than 0. So yes, these two pieces do define the absolute value function. Groovy. All right. Now, the other thing you're going to be asked is shown a graph of f, and you've got to sketch a graph of the absolute value. Well, you can imagine here, if you look at this line, f equals 1. So absolute value of f equals 1, right? So if the number is positive, you're actually just going to get, it's not going to change. If the number is negative, it's just going to flip up. So we should pop in this point here and see if we can match the y-intercept as well. There we go. So what you do is you just flip the negative bits up. Y equals mod f. Okay, so that's how you graph absolute values. You take everything underneath the axis, you flip it up above the axis. The other thing you might be asked to graph is f of mod x. Now, if we think about what's happening here, if I take something like x is minus 1, then mod x is going to be 1. So f of mod x is going to be the same as f of 1. So really at this point here, I want to mirror whatever the graph is doing at x is 1. So I'm going to have a point there on my new graph. If we take something like here, x is 2, so mod x is 2. So f of mod x is going to equal f of 2, right? So we do get a point there. So basically, to graph f of mod x, what you need to do is you need to keep the right-hand side of the graph completely intact. You don't mess with that at all, because mod x equals x over here. And then with the left side of the graph, you actually just make a mirror image of what was on the right side of the graph. So we'll pop that x-intercept there in as a mirror image. Cool. So that is y equals f of mod x. The original graph was y equals f of x. So yeah, mod of f, throw out the bottom, flip it up. F of mod, you've got to throw out the left-hand side of the graph and take whatever was on the right and flip it over to the left.